and the log of 12 is 1.079. So we're supposed to use those two values to evaluate the log of 1/3. How would you do that, Brooke? Because 1/3 and 4/12 are equivalent fractions. That's the actual formal name for that. They're equivalent fractions. So she took the 1/3 and made it 4/12. And then how does that help you, Brooke? Yeah, it uses these two numbers. So that's the goal. You're trying to use the two numbers that are given. So 1/3, a 1 and a 3, a log of 1 and a log of 3 are not given. However, you can change that and write it as 4/12. Now, how do you actually evaluate this? So now I have the log of 4/12. But what do you still have to do with this problem to evaluate it? Ella? Yeah, so that is the quotient property for logs. Division changes into subtraction of two separate logs. So the log of the numerator minus the log of the denominator. And then you just replace the values that you're given. So log of 4 is 602. Log of 12 is 1.079. And Ella, when you subtract those two, so the little trick to this one here was changing 1/3 to the equivalent fraction. And I think there was the one right next to it, I believe, was similar as well. Yeah, so number 12 gives you 1/3. So changing that to its equivalent fraction as well. Any questions on number 12? Sorry, number 13 gave you another one that you had to change to the equivalent fraction. We did number 12. All right, so the other one I wanted to look at was number 42. And I thought number 42 was a good problem. It contained grouping symbols, those parentheses. The directions for the group of problems here said to condense. And we have 2 log base 3 of 20 minus log base 3 of 4, and then plus 0.5 log base 3 of 4. So thinking about what you know with order of operations and also trying to use the property of logs, where do you think you would start with number 42? What would you want to look at first, Jaden?
You'd want to put the exponents back up to like where like the log base of 3 20 squared, and then log base of 3 4 squared, and then plus log base 3 4 to the 1/2.
So I agree mostly, but the squared is going to go on the outside. So we're going to keep it out there for a minute. So we're going to keep that little 2 on the outside because those grouping symbols say that you need to kind of perform what's inside of them first. Think of PEMDAS. You're supposed to perform parentheses first. But we can move the exponent to be up above those grouping symbols. And the exponent of 0.5 can go with the 4. So we can move those exponents. But if you look at the grouping symbols and you perform the operation inside, so we kind of canceled these out. Jaden, what would you do inside the parentheses?
I did. I did take the. I took 20 over.
Yeah. Oh, it's okay. So a subtraction sign, grouping symbols, parentheses, you do whatever's inside them first. So the log of base 3 of 24 becomes the log base 3 of 5. That 5 is what the exponent of 2 goes with. So that 5 becomes 5 squared. And then we have the log base 3 of 4 to the exponent of 0.5, or we know 0.5 is the same as 1/2. So the number in front goes as the exponent after you condense them together. So Grace, what do we do next? What is 4 to the 1/2? What's a 1/2 exponent really doing to the number? Square rooting it, yeah. So 1/2 exponent is really a square root. A 1/3 exponent is a cube root. So this is multiplying that then, or changing that number to 2. So we did the parentheses first, then we applied the exponents. And now we have an addition sign remaining. And Grace, that addition sign means, yeah, you multiply the two numbers after the log. So this becomes log base 3 of 50. Questions? So condense inside parentheses if there's parentheses. If there were no parentheses, then we would directly start with those exponents. The grouping symbols, whatever's inside those get to come first. But no, so we're trying to condense them. So we're trying to apply all of those properties together. Other questions?
So you can't do 1 squared divided by 4 squared.
Hmm.
Yeah, 20 squared divided by 4 squared.
What does 20 squared divided by 4 squared give you? Correct. So no. So when you have a quantity, that little, like that's grouped together, the exponent doesn't go inside the quantity, it goes to the outside. So it's saying that if there's really 2 of those quantities that in theory, if I had x minus 2 squared, this little squared, the exponent doesn't distribute to them individually. It means that there are 2 of those quantities there. So an exponent can't individually go to values, whether it's a log or an algebraic quantity. It means that there are 2 of them. So if you do whatever's inside the exponents first, then you apply that to, then you followed the correct order of operations. But an exponent doesn't distribute inside to a quantity to individual terms. Other questions? That was a really good question to look at and discuss. It's definitely a little more involved. Before we take a little quiz, if you just want to pull out your notes, I want to go over 2 more examples that we left yesterday. So if you could pull out page 20. Just as a little wrap up of this section, looking at page 20, we had condensing and expanding. And we have C and D to kind of just quickly discuss as a little review refresher. So part C, the directions say to expand, which is the opposite of what we did for 42. And we have the log of x squared y cubed. So Julia, what would you do first to try and expand this? So when we're multiplying, what is the property for logs when you're multiplying to make it separate logs? Yeah, you would add them. So log x squared, log y cubed. So to separate them, to expand, the product property separates into 2 individual logs that are being added. Just like the exponential property, if I'm multiplying, I add the exponents together. And then the next thing to look at would be the exponents in this problem. So it is an x squared and a y cubed. Julia, do you know what happens with the x squared and the y cubed, those exponents? Yeah, they move to the front and they go to the front of the log that they are attached to, and only the log they're connected with. So 2 log x and 3 log y. And then it's expanded. So I now have 2 separate logs. So the number of variables or the number of terms, each one gets its own separate log. So 2 variables means I have 2 logs. If there was a number in front of one of those variables, like if there was a 2 in front, then that 2 would get its own separate log as well. Anything that's being multiplied separates into its own separate logarithm. So the last one that we left yesterday, oops, God bless you, is letter D. So order of operations, PEMDAS applies to logarithms as well. You add or subtract from the left to right. So when you're looking at an expression, it's just like reading a book. You group terms together from left to right as you move across the expression. So the first 2 terms that we see here are being added. So by order of operations, you need to add those 2 because they're on the left. So Riley, if we add those 2 together, what are we really doing to condense them? So what does adding really mean if I'm trying to pull them together? What do you do with the 4 and the 20? Yeah, you multiply them. So to condense, to pull them back together, it means you multiply the values after the logs. So we got 1 log, and now it's the log of 80. And then we have minus log base 3 of 6. So moving from left to right, we do the pair on the left first. To condense them, to pull them together, we need to add them together. Gabby Soul, what do we do next? Yeah, so now we're going to divide. So again, to condense them, subtraction means to divide. We're dividing the numbers after the log. Remember, our goal is to have 1 single log. So I have the log out front, and we're dividing 80 by 6. So you only are dividing the term after the log. That's what you're really pulling together. And 86 reduces to 40 over 3. So when you have it as a single log, it's then been condensed. Questions? The last little thing about the change of base formula, if you don't have that fancy button in your calculator, so we have the log base 16 of 26. There is a workaround, and if you don't have the little button, then you just need to take the log of 26 and divide it by the log of 16. Some of you may not have that button in your calculator. The key thing, though, is that you must use grouping symbols around them to get it to work correctly in your calculator. So the change of base formula, most of you probably have the little function in your calculator that you can just hit the button and you can plug in the 16 and the 26. But some of you may not. So if you don't, then you just need to do the logs individually. So I would just take the log of 26 and the parentheses though, and then the log of 16. You get the same answer. So it just depends on the year of your calculator, the number, whether it's an 83 or an 84, and if it has that feature. So it wasn't originally in some of the other calculators, and then they added that as an extra option. Are there questions? So I have that teeny tiny little quiz to give you. If you are at home, you're going to go to Google Classroom. Some of you will not have this open for you because you're signed up to be virtual, so you'll have to, or I'm sorry, signed up to be in person. So you'll have to give me a minute to open it for you. But those of you at home, you can go to Google Classroom and there is a short little quiz. And you can stretch, Cody, you can stretch those arms so that you can grab your quiz. So this is just a short little quiz. Can you convert? Oh, thanks for standing up. Can you convert from one form to the other? Can you solve the equation by converting it to the other form and solving for x? So just a short little quiz to make sure everybody's okay with converting. No calculator. No calculator is necessary. And again, if you're at home and you're supposed to be in school, I need to just open this quiz up for you. So this should not take very long. When you're done, the worksheet will be posted, which is just a review of the two sections 7.4 and 7.5.